Hello, fellow systems engineers, and welcome back to a new episode of the MBSE podcast. Today, we are talking about a topic you might have heard about, especially since ChatGPT went viral. It's about artificial intelligence and how artificial intelligence and systems engineering can interact and how they can benefit from each other. For this topic, we have two guests here, authors of a book, but we will hear about it later. It's Giovanni and Alessandro, both Italian guys, one living in France, one living in Italy. But yeah, Giovanni, Alessandro, please introduce yourself.
Okay, thank you guys. At first, I want to thank the MBC podcast for inviting us. And I introduce myself. I graduated in mechanical engineer at Federico II in Napoli. And I awarded a second level master degree in systems engineering at Missouri Science and Technology in USA. I worked a lot in continuous airworthiness in the subject matter experts, in the configuration control, and I took a critical interest in the decision-making process. By different mathematical approach, indeed, I presented at ASEC 2014 a decision-making algorithms in the sport business. Over for my side. Thank you again, Alessandro.
Okay, same from my side. So thank you for having us. Well, my name is Alessandro Migliaccio. I also graduated in systems engineering, and I started the same as Giovanni in Napoli, in Italy, for a bachelor degree. Then I moved to the Netherlands, where I studied space systems engineering, which was very good because it gave me the basics of systems engineering methodology, which so oftentimes is not taught at university extensively. Then I continued with I did my internship at NASA Langley, and then I moved to back to Italy, where I did a postgraduate master in robotics and industrial automation. Which opened a little bit my mind, my young engineering mind to the world of artificial intelligence and, industrial automation, which is essential in the field of aerospace engineering, as well as other fields of engineering. And then I've been working as a structural engineer on different Airbus aeronautical programs as a subcontractor. And then I joined Airbus in the UK as a stress engineer, in particular fatigue and dementia tolerance, for people who know a little bit the subject. But in the last few years, I've been working in systems engineering in Airbus in Toulouse, in the systems engineering department. So our job is to support all the different Airbus programs by sharing with them and supporting them on systems engineering methodology. And my specific job is a business product leader for the software doors. So I make sure that the software door supports the needs of the business and is correctly developed for the development of our legacy and future aircraft programs. I also president of the association AI Shed, and under this banner, myself and Giovanni have written the book Systems Engineering Neural Networks that we are going to talk about in this episode. Over.
All right, so yeah, welcome also from my side. I'm glad that you are here. And well, as Christian already said, we announced the podcast with MBSE and AI, and these are two hot topics at the moment. And your book is called Systems Engineering Neural Networks. So neither MBSE nor AI appears in the title. So how does this all relate, or is our podcast title just a marketing eye catcher?
Yeah, well, Tim. So Okay, thank you for your question. So, well, we started writing our book 7, 8 years ago, almost. We decided to cover two important topics, and we believed that this topic uh, will be profitable in the next future. And so we were passionate in the about artificial intelligence, and so we want to introduce the systems engineer approach for artificial intelligence application. We could say that model-based systems engineering is a subset, of course, of or an expansion of a general system. Just AI is a broad term that encompasses several technology from so machine learning to robotics. So if we want to start from in-cause definition of MBSE as the formal application of model to support engineering task, and therefore the essence of MBSE is based on the application of models that can be applied to a system or to systems that are existing systems that already exist in the reality. Now artificial intelligence can be defined as an ultimate expression of reality, because we figure out artificial intelligence with the human brain. To date, there is not a very tangible comparison between artificial intelligence and the human brain. For instance, for example, the human brain gets a lot, billions and billions of neurons, for example, and we have to explain the empathic characteristic of human beings. It's not easy now to express these empathic characteristic by artificial intelligence. But in our book, we focused on the need to build the model closer and close to the characteristic of the human beings, like a model of artificial intelligence is the neural network. Of course, we can extend our text to the MBSE approach, because the MBSE is the systems engineering with the usage of models. And this is our this was our intention. Over.
Okay, yeah, very interesting, very interesting. And so I don't know where to continue exactly, because there are so many interesting things about it. Can you give us a little bit of an overview of the book at first?
Yeah, so I mentioned it before. So we spent a long time thinking about making the right decisions, and we want to create, or we want to build an artificial support that help us to make the best decision. And so think about how we do it. Okay. We do know that our brain processes millions of data simultaneously, and sometimes we do not have realize that a synaptic journey has taken place. Now, every day, so we deal with problems that can be seen as optimized complex system. AI is an enabling technology to allow such optimization. In our book, we started from a machine learning technique just to emphasize a model. We decide to choose this model just to explain in our book that we can apply the systems engineering methodology on the AI model. So our book aims to discuss such model according to the systems engineering approach. Once we have defined the system, which to apply this model, we try to introduce the neural network according to methods and processes recognized by the systems engineering philosophy. This allowed us to show that the application of a neural network, like a model, cannot be beyond the deep knowledge of a system, because the neural network is itself a subsystem of an existing system. And so we introduce the neural network model in a existing system, for example. After this, we can build a software, we can code, we can create coding of a neural network model, because we can explain this by a mathematical approach. But it's important to, let me say, we have to pay attention that the neural network is a configuration item of our system, becomes a configuration item of our system. And this is explained in our book.
If I can add, the initial idea was that, I mean, systems engineering is a very powerful tool that helps us to manage complexity. And well, if you think about the Turing test, we say that a system is artificially intelligent, when we can pass the Turing test, so it can demonstrate to be able to behave or like a human, so to be indistinguishable from a person. If you talk, if you don't know, the Turing test, it's about, trying to interact with an entity, and you will not know if it's a human or it's an artificial intelligence, and you will not be able to say which is which. And imagine like the terrible complexity associated to this task. We are trying to imitate the human brain or to create a system. Then imagine like a self-driving car needs to make decision, to turn right, to turn left, or get into traffic. And what amazing level of complexity, needs to be managed. And for us, it was obvious that systems engineering would be the tool to manage this complexity. So it was really a no-brainer, no pun intended. Yeah.
Well, you said no-brainer. Yeah, writing a book is a huge effort. So, and it lasts many years, even if it's for a no-brainer. So, what was your motivation then to write the book? And you published it with Wiley, if I remember correctly. So what was the initial trigger to do that?
Yes, Tim. So I told before, maybe I hope that it was understand. We believe it's important to treat the artificial intelligence as a system. And as a system from an engineering perspective. So our objective is to create a artificial intelligence engineered. Okay, this could make it possible to gain significant benefits, not only during the design of artificial intelligence, but also its management phase by establishing up to ends of life. The main it was an occasion to study as well the regulation of systems engineering, and we saw that the regulation of systems engineering help us to treat artificial intelligence as a system. So we study in the critical perspective the systems engineering regulation, and we saw that the regulation of systems engineering help us to treat artificial intelligence as a system. And so we want to motivation, and we hope so to give a chance to people like us, like you, which creative and passion to put this technology to use is the creation of quality products.
Exactly, Giovanni. In fact, our initial concept for the book was to create a sort of like artificial intelligence for dummies type guide, because we were a little bit like frustrated with the fact that such technologies that are regarded as niche, like now it's mainstream, but when we started 10 years ago, it was a sort of a niche, at least in the engineering, the systems engineering domain, and we wanted to give opportunity to engineers like us, but all sorts of creative people working on it as a hobby or in big companies, to be able to do it themselves, because now coding's at our fingertips, all these technologies are at our fingertips, and we don't need you don't need to call the AI department of your company to do an AI project or a data analytics project. You can sort of do it yourself, depending on the level of complexity. And large language models, they come already pre-trained, and you can reuse them by downloading them from the internet. So it was the idea was to democratize technology by bringing to the people that want to use it, without having them blocked with company bureaucracy or your budget request or return on investment, because niche technology and innovation and return on investment don't always go hand in hand. So that's my take on it.
Okay. Yeah, what would be interesting for me still, how would you relate the definition of the term system to AI? So we heard a little bit about it, but I think there is more behind it.
Yes, Christian. So our personal experience through with the knowledge of its results from the development of a previous experience, a system, we think that a system is not something presented to the observer. Like an artificial intelligence, we want to build a right artificial intelligence. We have to observe the reality, but something that must be recognized by an observer. The system, or the event in general. Generally speaking, we want to describe an event, and something must be recognized by an observer. The same observer has to create the artificial intelligence. Now, knowledge of a system depends on what is observed. This implies that the knowledge of a system is more limited if the observation is not accurate. It's the same for the artificial intelligence perspective. So when we want to associate a real system observed with some levels of detail, I don't know, so the example are a lot, but generally we want to explain an event or a system like a model, physical or mathematical. So we studied a lot of model in our courses in the past. Now, we must take into account that all information needed, so about the state and behavior of the system, are observable, accessible, measurable. It's important that we have to measure the event. Therefore, according to above approach, an AI can only be understood as a whole science and analysis of its individual parts might be incomprehensible because of their complex interactions. This is our approach, AI and system, and we have to put together these two maybe different, maybe can be different topic, but we saw that are very similar.
Okay. Roger. Yeah. Well, in the context of systems engineering and AI, there are two streams. So AI for SE and SE for AI. And I saw both terms in your book. So what does AI for SE mean?
Yes, this sort of two pieces of terminology. They appeared a few years ago, I believe, during some international event that was related to systems engineering, and it became part of a sort of like the jargon. So in reality, you know, any technology that you can summarize in acronym can be associated with systems engineering that way. So AI for SE, what does it mean? Well, basically, what we talked about in the book for AI for SE is how artificial intelligence can support systems engineering processes. So if you think only like the system life cycle, you know, from the stakeholder management or the understanding, you know, the definition of initial requirements, to maintenance, to the deployment of the system, AI can support all of these different phases. You know, for instance, we know that the concept of operation or ConOps is one of the basics of systems engineering, at least like the document-based approach. And I've seen example of ChatGPT used to generate ConOps. So you can ask ChatGPT to generate the concept of operations, and it, since it's a large language model and these documents are just like language, it can generate with the various degrees of usefulness and accuracy, but it can generate a ConOps. So we believe it can be used in that phase of the system lifecycle, for instance, but not just that. So it is my sort of projection, you know, as an aspiring futurist, that since ChatGPT can generate code and can make illustrations, and how like engineering level validations are done through engineering models, that with an implementation similar to ChatGPT in the future, it will be possible to ask the AI to generate a let's say a structural model of some component of an aircraft, and being able to, so that the AI will generate it for you once you give it the necessary constraints, the boundary conditions. So for me, it's absolutely possible. It's just an extension of what we already have. You know, we have already powerful tools and powerful AI tools. We just need to combine them. So that's, for me, is what AI for SE means. So it's AI in support of systems engineering processes and phases of the life cycle. The opposite, SE for AI, is how systems engineering can to the rescue in support of artificial intelligence. Let's imagine systems that are AI heavy, a self-driving car or a rover on Mars, that make autonomous decision. Autonomy, for instance, for space technology, autonomy is absolutely essential. Satellites and other like spacecraft, once they're launched, they have very limited contact with their base. So they need to be semi, not entirely autonomous. And for that, you need AI is already implemented. What is new about it is that systems engineering process is very helpful, because projects that are AI, for instance, that rely on data analytics and machine learning, need to be designed from the very beginning with this in mind. You cannot just take a system and say, okay, I add AI, add AI enhanced. No, it needs to be designed from the very beginning with AI in mind, because, for instance, the systems rely on the use of artificial neural networks. Neural networks need to be trained with great vast amounts of data. And where is this data come from? From sensors. So you see, you need to design the system with sensors in mind that can acquire the data, then and the data also needs to be real time, but you also need to have data provided externally, so you can train the neural network even before your system is deployed. So you need to think about the phases of the life cycle. You need to think about the right requirements. It's just it's a little bit like project management. When you start a project, you need to start anticipating, later phases of the project to be prepared. I think with systems engineering, AI systems absolutely require systems engineering thinking, because those techniques allows us to do not only the system right, but also the right system. And that's valid also for AI systems, and as imagining again autonomous systems, there is no margin for error. When the satellite is launched, you cannot go back to the drawing board and try to fix it later. I mean, it's been done with the Space Telescope or with some other, but it's very rare that you can do it. So systems engineering is absolutely essential, especially when dealing with autonomous systems that are, as I said, AI heavy.
Tim, you wanted to add something?
Yeah, so we talked about AI for SE, and has had this example with ChatGPT writing condops and so forth. So just reminded me of recently we used ChatGPT, for example, to find a list of potential stakeholders for a project. ChatGPT is not very accurate at the moment, but it's a very good sparring partner to get some inputs. And we asked ChatGPT provide us a list of potential stakeholders, and a very long list for potential stakeholders. And we got 60 stakeholders for a specific domain. And well, most of them are quite obvious, but there are also some very good ideas in there. So it's we can already use AI for SE. So very well. And SE for AI, if I understood correctly, is a little bit like the approach you used in your book, right? You mentioned before that you use SE, systems engineering techniques, and apply this to AI, right?
Yes, as Giovanni could tell you even better than me, just about generically applying SE techniques to artificial intelligence systems, but it's like in what phases of the design of the system you start thinking about your AI consideration. We're not talking about designing an AI system per se, but a system that has an AI component. If you think about it, a lot of a mobile phone, a smartwatch, or a lot of things have some level of smart, Internet of Things and so on. Most of the systems that we deal with on a daily basis are smart, and that intelligence needs to be designed into the system from the beginning, but also needs to be understood. It's like, okay, what about imagine like you design, sometimes I use example of the wind tower, for electrical generation, wind turbine, okay, you design it, okay, if I have systems engineering principles, but what about, it's offshore, how are you going to maintain it afterwards? Are you going to send a ship every time, or you want to send some drones to do inspections to this offshore, power plant. And of course, you need to design it with in mind already. It's like, okay, how are you going to train these drones to recognize, let's say, cracks in your power plant or the structure, and that needs to become very early on. So you need to design and follow really your system life cycle with the AI in mind, and again, not as an add-on afterwards, something, okay, I'll do some AI to make my system smarter. I don't subscribe that that's a very good way, although it can be done, but maybe it's not really the most efficient way to go about it, because it would be a little bit like correcting an error later in the life cycle rather than correcting it at the beginning. So again, for me, the use of SE for intelligent system is absolutely necessary.
Okay. Yeah. Yeah, but can you again explain a little bit how the model-based approach can be linked to artificial intelligence?
Yes, Christian. So, so the MBSE philosophy, for the MBSE philosophy, a numerical simulation is very useful since it provides artificial but concrete models. Some model can reproduce reality an infinite number of times. So we decide to reproduce an aspect than other. So we want to move in the details of the event. So, but a first step, anyway, a first step will be to link formal methods by formal methods and formal techniques used in numerical development of a complex systems, in generally speaking. Moreover, anyway, so the tangible advantage of MBSE methodology is the verification that we can verify that the system operates in accordance with the established requirement, established before starting to create a model. And this numerical simulation testing will provide comprehensive coverage of the function, requirement analysis, and design of the mentioned system. We can, so the MBSE approach can be linked to artificial intelligence, so we have to define artificial intelligence like a system. And we can reproduce this system like a model.
Okay. Well, AI is very good at solving special kinds of problems, like analyzing tons of text and tons of images and so forth. So where does that fit best in model-based systems engineering? Where do you see special areas where you can apply AI very good?
Alessandro,
yes.
want to?
Yes,
okay.
yes.
Okay. Thank you.
So yeah, well, for instance, like in we've seen that AI, can is very good, as especially in the book we talk about neural networks, because it's one technique that we felt would be very powerful. But there are other techniques of artificial intelligence are very useful, and the beauty of it is that while we cannot reproduce like a general intelligence, like what the human brain can do, but these techniques are very powerful on specific domains, such as like the requirement. So it can be used for requirement engineering, image classification, like the example of the drones for inspections, for instance. There you need to collect lots and lots of images, then you need to train your algorithm to detect specific features in those images. Imagine you want to detect some structural issues or some damages. How the artificial intelligence is going to know what is broken and what is not broken. We learn by experience, but we needed to give the same experience to the algorithm by training, for instance, a neural network. Prediction. So what's going to happen in the future based on historical knowledge? COVID-19, algorithms of artificial intelligence have been used to predict the propagation of COVID-19 based on historical data from different epidemics. And so prediction is very important. So in the book, we talked a lot about prediction. Also because we made an interesting, a bit unusual case of trying to model like a human system, like a sport club, and how different athletes, the performance athletes would be in the future based on their historical performance. And will not be a first time artificial intelligence has been used in that for that purpose, but not while trying at the same time to model a sport club as a system. And this would support also computational decision making, because how would people, how do people make decisions? They make decisions, based on experience of trial and error and so on, and we can provide to algorithm that same experience so that they can I don't say make decisions, but they can provide enough data to the human to make informed decision, and maybe eventually make decisions themselves. So these are important advantages of artificial intelligence techniques that can be helpful in a systems engineering context.
Yeah, let me add, so just to close.
Please.
Yes, just so we believe that artificial intelligence should not be treated externally to the system of interest. So once we have defined the system of interest, we can apply in the system of interest our artificial intelligence. And so it's usually to start from a system of interest. Over.
Yeah. Oh, we are running out of time a bit, no? That's an exciting topic. Well, then, I heard that you already work on another book project, also in the context of AI, I guess. So can you talk a little bit about that?
Yes, we I mean we are we are trying to we are trying to use different let's say to evaluate different technologies in combination with model-based systems engineering and systems engineering, because we believe that there is a lot of convergence. Systems engineering is really, and a model-based systems engineering as an extension of the document-based approach, it's really an enabling methodology that can support the deployment of different type of technology. So, for instance, we are looking at the convergence now as a sort of a new area of research between enhanced visualization techniques, immersive technology such as virtual reality and augmented reality, in combination with model-based systems engineering, because the basic intuition, which is not really a rocket science, is that virtual reality, and in general immersive technology, can provide advanced visualization capabilities, while model-based systems engineering relies heavily on modeling effort. So it seems obvious that at some point in the future there will be a convergence, and advanced visualization will be an essential tools for systems engineer to, for instance, perform verification and validation in virtual reality. You know, there are some things with some limits to the modeling. You know, you want to try the ergonomics of a different, you know, of sitting into an helicopter of some sort and see how it fits while you're sitting in the pilot seat, you know. And how would you do that before building, you know, the mock-up of your system? You know, you can do it much earlier, you know, with virtual reality. You know, it's the it will bring the modeling effort to its full potential. And the next book we are exploring exactly that. So how to provide techniques that would be useful to systems engineers to make full use of immersive technologies, you know, for their modeling efforts, for verification and validation, for design. You know, even the ConOps mentioned before, you know, can be visualized through simulations in virtual reality. It could be potentially much more effective than document-based, you know, scribed ConOps in writing. You know, so that's what we are working on. And maybe it's a discussion for another time. It could go on and on about you know, the convergence of many technologies with model-based systems engineering. Really, I don't know if I entered a bit of the question. Or...
No, that's fine.
It reminds me of a project. It was a research project more than 20 years ago with UML. And they had the plan that I can walk through my model. And the model is still two-dimensional diagrams, but they use the third dimension to show the status of this model element. Like walking through a housing development area, and I can see, so, oh, this house is already finished, and here's some work to do. And so that was their idea. And I saw the prototype was a nice idea 20 years ago. So it was.
and the advantage would be, you know, imagine that if you could see the virtual representation of your system, be able to not just like to open it up and disassemble it, and they do it like cooperative design reviews, you know, with other engineers, you know, in other parts of the world, or people, you know, okay, doing virtual meetings is already possible. But what if you could, you know, take a piece of your system and connect it through your entire, you know, documentation to the initial requirement that generated the system, or back to the driver, you know, that system. You know, when I joined the engineering community, I had exactly this problem. It's like, okay, the airplane or whatever system is built this way. And why is built this way? Oh yeah, because the designer 20-30 years ago decided that was the best way. We no longer work like that. You know, we build things according to system specification that are derived from our stakeholder requirements, that are derived from our company's value drivers. And all this chain of information is not easy to. And that's the potential of you know, PLM solution. And for me, it will be greatly enhanced by this. You know, we need, you know, models are mostly, not always, 3D. So for me, the 3D would be the way to go. But also a very good connection with artificial intelligence, because enhanced visualization, think about augmented reality, without artificial intelligence, it's really meaningless, because yeah, you have smart glasses that can show you amazing things. But okay, but those amazing things are not related to what you're doing at that precise time. They are based on actual use cases, or they give value, you know, user value proposition. What do they do for you? You know, like you can put augmented reality glasses during a sport match, but if they don't give you real-time statistics and analysis, you know, which give you like relevant information to follow that specific event, they're really useless. So AI, model-based systems engineering, and enhanced visualization, they're all connected, in my view.
Yeah. So, well, now we are running really out of time. So, yeah, Giovanni, Alessandro, it was great to having you here in our podcast. Very interesting topic, and I'm pretty sure that we will have other episodes in the future about AI, virtual reality, and all the stuff. And it will be quite important for us systems engineers. Yeah, so the next topic, well, it's not finally decided yet. So Christian and I already discussed what could be the next topic and who do we invite. So stay tuned. We will announce it soon. So, and also the date is not set, but approximately in a month or so, as usually. So, and well, then with that, I close with, do not forget.
Give us a thumbs up, hit the subscribe button, and trust us, we are systems engineers.